Now let us see the algebra of vectors. That means how can we add or subtract two vectors and so on. Now the first law used to add the two vectors is nothing but the triangle law. Now let us understand what the triangle law is. Let us consider that there are two vectors, say a bar and b bar, and we want to add them. That is, we want to see what is the net result of these two vectors, or in other words, instead of considering these two vectors, what is the net single vector which has the same result as the result produced by these two vectors? What is that vector and how do we find it? So for that we have to understand the triangle law. Now to use the triangle law, what do we do is, first of all, let us draw the original or the one of the vectors, say a bar, like this, and wherever the first vector ends, okay, that is called as a terminal point. From there we will draw the second vector, of course parallel to itself. So therefore a bar and b bar being the free vectors, I can shift b bar to a line parallel to itself, right? And at the end, what do we do is, starting with the initial point of the first vector, we join it to the terminal point of the second vector. Alright, so it looks like we have completed a triangle, and this third side is precisely the addition of two vectors, a bar and b bar. Right? So just to repeat, to add the two vectors using triangle law, take any one of the vectors, say in this example a bar. Okay, wherever that a bar ends, you attach the second vector and then complete the triangle from the initial point of first vector to the terminal point of the second vector. So this newly joined vector indicates the addition of a bar and b bar. So we also call it as a resultant or the vector addition of two vectors. Okay. Now the same can be achieved by a slightly different perspective, that is called as a parallelogram law. It's really not fundamentally different, but it's just another way of looking at it. So let's take the same example again. Suppose we have a bar and b bar as two vectors to be added. Okay. What do we do is, instead of completing a triangle, now we complete a parallelogram by combining the starting points of both the vectors. That means we join the two vectors such that their starting points, their initial points are the same. Okay. So here we have a bar and b, and now we complete the parallelogram by drawing the parallel lines through the end points of both of the vectors. So here we will see that we have completed the parallelogram law, right? And now through the common point, common initial point, we draw the diagonal of that parallelogram law, and this diagonal represents the resultant of two vectors. And in fact, if you see the portion of one of the triangles indicates the triangle only, so therefore it is same as the triangle law, and hence the parallelogram law is just a different way of looking at the triangle law. Alright, so that was about the addition of two vectors. Let us see how to subtract one vector from the other vector. That is, we want to do a bar minus b bar. Let's consider once again a bar and some vector b bar. Now we just do a little mathematical adjustment, that is a bar and minus b bar we can write as plus of minus b bar, isn't it? Because subtraction is nothing but addition of the opposite. So minus b bar is nothing but a vector which is having the same magnitude but exactly opposite direction of the original vector. So it will be in anti-parallel direction, and we have to now merely add a bar and minus b bar, and we already know how to add any two vectors. So therefore we take a bar, then we attach minus b bar at the end of a bar, and then completing the triangle, that is using the triangle law, what we obtain is nothing but a bar minus b bar. So that's how we do the subtraction. Right. Let's move on and see how to multiply a vector by a scalar. So by the word scalar we mean a pure number, a real number, a constant. Of course it has to be a non-zero number. So suppose we have some vector a bar, okay, and I want to multiply it with 2. So what 2a bar looks like is, I am going to double the magnitude of the original vector. So it's like I have stretched a vector by a factor of 2. Suppose I want to multiply that vector by 1 by 3, of course the original vector. So basically what it means is I will have compressed the original vector by a factor of 1 by 3. So that is the meaning of multiplication of a vector by a scalar. Now let us summarize some of the important results based on addition, subtraction and multiplication of a vector by a scalar. So these are the very important laws that we have to use in many situations. Let us go over them one by one. So let a bar and b bar be two vectors and let p and q indicate the scalars. So therefore the first result is a bar plus b bar is equal to b bar plus a bar, which is called as a commutative law. So what it means is, while adding the two vectors, the order of vectors does not matter. So even if you change the order, the final result will be the same. Second one is a bar plus b bar plus c bar is equal to a plus into bracket b bar plus c bar, which is also equal to into bracket a bar plus b bar bracket complete plus c bar. And this is called as associative law. So what it says is, suppose we have three vectors to add, then we can add any two vectors first and then add that result to the third vector. So the final result will be the same irrespective of which two vectors you add first or associate first. So therefore it's called as associative law. Third law says that p into bracket a bar plus or minus b bar is equal to p a bar plus or minus p b bar. So this is like distributive law for p to be distributed to individual elements inside the bracket, and this is what we do in algebra also whenever we want to expand the brackets. On the other hand, fourth law is also very much similar. We have into bracket p plus or minus q times a bar, which is equal to p a bar plus or minus q a bar. Right? So we have to use these laws as and when required while dealing with sums on vectors.